Hello friends, hello few skeptics and future customers. I'm Scott and welcome to another day out in the garage with the rollers. Here we are with our 4-inch diameter roller, and we are going to be doing, for the first time ever, a demonstration video on how to motorize your hand-powered roller. So my friends and family always ask, who buys these roller things that you make? And so it's a hard question. I tell them it's anybody who needs to make something round. If you look in industry and in construction and in nature, there's so many round things. It's sometimes art companies and contractors, and it's just small business owners and hobbyists like you guys who need to make something round. So leave a comment below of what you are making or need to make. And we're really thankful that you guys are making cool things here in the United States. And this machine is 100% made in the USA, here in Washington State, by me and my team. And it's made of all USA steel. I believe that this is the best value roller you could buy. These things are great. You can roll some really thick material for them. All of my rollers are under about $3,000, except for the really large ones. And you can roll round material in this groove on the side. If you put the rollers down into lower positions, you can roll square and rectangular thin wall tubing. They're just really capable machines. I had a customer reach out just a few weeks ago who makes the hardware around manholes. And so today we are going to be making a manhole ring with this. This is 1/4 inch thick by 6 inches wide steel, hot rolled steel. I don't need a manhole ring, and you don't need a manhole ring, but you need to make something cool and round, and so we're going to make one anyway. So the question of how to motorize these rollers is pretty tough. Your roller has to be really high torque. I tell people somewhere in the neighborhood of 100, maybe 200 foot-pounds of torque, and really low speed, so to the tune of perhaps 1 revolution per second, 60 RPMs. And there are some motors out there that can do that low of speed and high torque, but then the issue comes into its movability. So not only would it have to move up and down, but you need to be able to move the motor to the other side. These are just grade 8 bolts into the rollers. And another question that we're going to try and answer today is how consistent and accurate are these rollers? And this is an all manual process. You're doing the rolling with your fingers almost all the time, and so you can be really consistent. In terms of accuracy, it can be really good. Probably within a 1/16 of an inch every time. About as good as you can be with a tape measure. If you're really patient and you want to use your calipers, you can be better than that. So I cut my material a little bit wrong. So we're going to be making a manhole that's 16-inch manhole ring. That's 16 inches in diameter. I know it's a little bit small. 16.5 on the outside. You have to accommodate for the flats on the end of your material. And that flat is about proportional to the distance from your center roller to your outside roller. People always ask me, can you use your impact or a drill to power these rollers? And I always say, no, you cannot use your impact. These are right-hand thread bolts going in, and if you impact them out in, you're never going to get them out, and your impact is not low enough speed. But what we're going to be using today, I came upon this, and this is the M18 Milwaukee Super Hawg right angle drill. They make one of these for electricians that's about 7 pounds. And that's not it. This is the one for plumbers. This baby is like 13 pounds with a battery and a adapter and an 1.1/8 adapter ratchet socket on the end. This thing's about 16 pounds. And the reason I got this one is because it is fully variable speed. You don't need variable speed, but you need low speed. And so I can keep it pretty slow as we go. All right, enough talking. Let's make it. I have my material set in. There's nothing special about the material, just plain steel, hot rolled. And make sure you get the rollers leveled, which is something I just did. So this is how you normally do it. You roll right to the point where the material is on the top of the roller. And then you tighten it down and roll it back. So because I have used this roller a lot and this bolt is in here really tight, probably too tight, I'm going to try doing this thing on left hand for the counterclockwise movement. Ooh, almost went too far. And because it's in the widest position, you can go down with your compression bolts at a faster rate. So that's 2 turns. The other feature of this drill is that the electrician version does not have is this high-low clutch. And so you're going to always want it in low gear. And 2 turns barely did anything. So we're going to do 3. 1, 2, 3. 1. Came out. So this kind of thing, you can count your revolutions and set it back, or you can just loosen it a whole bunch. Put it back in, make sure it's straightened, and then level it again. Alright, I'm going to try not to goof this up this time. I'm going to manually put it right to the very edge. So this thing has a clutch inside, which is what's stopping it. Well, that's not good. So I guess 3 revolutions puts a little bit too much torque for even this motor. So we'll do it with a little bit less compression. So another thing that you'll want to be aware of is that your steel, especially hot rolled steel, has got this flaky surface. And after you roll it, perhaps this much, maybe even a little bit less, the compression on this type of the side of the steel and the stretch in the outside of this is about enough to cause a lot of this stuff to come off. And so you'll start to notice this pretty thick dust. And so take some real rough sandpaper, and you can just do this by hand, and scratch it off. Take your little hand broom or something with compressed air and blow it off. And the cleaner it is, the better your contact, the better your friction, your ability to roll things through and not damage your rollers. Full battery. Yeah, I'm not sure why that's doing that. That's not working out very well. Try one revolution. Well, that's strange. I guess we're doing it by hand. So another trick you might do to try and get a little extra, or to reduce the flat on the end, is when you tighten it all the way, you can tighten it in the middle of your roll. I tend to do it at the end of the roll. Once you tighten it, you can put a little extra pressure as you're rolling backwards, like this, to try and get that bend to stay near the edge of the flat. Well, that sometimes works. So it's a little bit harder to roll for the first, say 7 inches, because the flat is coming out, and once it gets to the smooth part of the roll, it seems to be a little easier. Yeah, a little bit too high a torque. Even this plumber's Super Hawg just can't put out 100 or 200 foot-pounds. try it again being gentle with one revolution here. So then I'll do a few inches. That seems to work a lot better. You're going to do a lot more passes if you're only doing one turn of the compression bolt every time. Well, there's got to be some smart system inside of this that senses too much torque. So I'm going to do a full 3 turns this time, and you'll see the diameter change a lot more. This is my favorite part of the rolling process, when you watch these two edges come really close to each other. I think 3 turns might cause this to hit, so I'm just going to do 2. Alright, so that's another 2 turns, and that should certainly make these 2 edges hit, and that's okay. Well, you know this is 1/4 inch thick steel already, but I'm just going to demonstrate that even with compression on the center of the steel, there still is a substantial amount of flex to it. So now we're trying to make this side tighter, and this side is larger, so this piece itself on the top has more flex. So that's what we're going to put on the outside here. And this is the point where we got to cut these off, because we can't roll any further with this piece hitting the roller. Well, this is the point in the show where you take your favorite cutting tool and cut off these flats. If you're using a plasma cutter, you're going to have a little bit rougher edge, so you're going to make sure you want to clean that up. You're also going to blow a little bit more debris into this crack here at the bottom of the roller. But an angle grinder will work fine for most of you guys. Grab a scribe and right angle, and try and make your cut as square as you can. You're going to cut the flat off, and you can do this in stages if you want. Sometimes you can cut, some of the flat off, and cut some of the flat off here, roll a little bit more, and then you still may have a little bit of not perfectly circular section for this outer little lip here. I'm just going to cut off right where I see the flat ending. grinding or finished with your work, you want to grind the outside edge, because this outer edge is what's going to be laying on this piece's tubing for your roller. The inner edge doesn't matter quite so much unless you are doing this without gloves on and you don't want sharp edges on it. And make sure to grab your broom and brush all this dust off. All right, I'm gonna bring the camera in here so you can see. I rolled this all the way back and forth, and you're like, well, why doesn't that line up? Well, the reason is because there's pressure on the roller from our compression bolts and on a pressure roller. It makes this not quite perfect. And I can roll it back and forth without doing anything on the compression bolts, and that will just move around as we roll it back and forth. But you can see a little bit of the unevenness of the end of your piece of material. I have one customer who makes centrifuges with these rollers. And so I imagine that he started with perhaps, he did say they were about 18 to 24 inches in diameter. So you're probably looking at least 24 inches of extra material so that you can cut off. Not sure if my eyeball's deceiving me. It looks like this section here is a little bit different than this curvature here. So this is where we're going to take a measurement and start approximating how much we cut off. We're going for 16 inches and we're at 18 and some change. Well, if we're going for about 2 inches, 2 times pi is about 6 inches. So we're going to cut about 3 inches off each side here.